Hi, let's go on to multiplication then. Now, what does it mean to multiply something by, say, 3? It means take whatever we have and then make 3 copies of it. So we represent the multiplication by a number as a copying machine. Take something inside the slot and then make 3 copies out of it. So for example, 2 times 3 would be, put 2 dots in here and then make copies. So 2 dots in here, 2 in here, 2 in here. How many dots do we have in total? 6. What is 5 times 3 say? You make place and then we insert 5 dots. And 3 copies of the 5 dots give us 15 dots. What is -1 times 3? That is, we insert a single anti-dot. We just copy what's in there. We could make an anti-dot, another anti-dot, another anti-dot, -3. What is, and at this point, okay, let's ask what 8 times 3 is, and instead of having to wipe away the things inside this copying machine, we just make copies down here. So we keep these empty boxes up here and then we make copies of this copying machine and insert whatever you want down here. So for example, if we insert a variable a, we get a plus a plus a. What else can we find out about multiplication? Well, there's a very well-known property of multiplication that it also commutes. So that a times b is the same as b times a. Let's check this with an example first. So let's take 4 and 5. So a would be 4 and b is 5. So we draw a machine that gives us 5 copies. And then we insert into this machine 4. But let me write this 4 not as 4 dots, but as 4 squares, so to speak. So we get an array of squares. This is 4 times 5 gives 20. And let's also draw down here the original multiplication machine by 5. So 1 times 5 gives 5. 4 times 5 gives 20. But we can also look at this the other way around, like a multiplication by 4, which is applied to 5. So 4 times 5 is the same as 5 times 4. And you might recognize that this has nothing to do with 4 and 5. We could use variables. Let's write this with variables. If we use variables a and b, we do the following. We start with 1 dot down here, and then we write horizontally, say, the multiplication machine by a. So 1 gets turned into a, and let's write vertically the multiplication by b. So this is times b, and then you already see that we can think of this array as being a multiplied b times, or b multiplied a times. So in any case we get ab. Okay, what if we don't put 1 in here but something else? Let's say a third variable, c. So instead of c we get here c times b, and here we get c times a. And here we get, well, either c times a times b or c times b times a. Let's take this version here. And we've already seen that the overall effect is to turn this 1 in here, if we insert 1, into AB. So the whole effect of this array is a multiplication by AB. So we see that if we take C and multiply by A, and then multiply by B, is the same as taking C and multiplying it by the product AB. So we have commutativity and associativity represented in this diagram.